All right, welcome. Today, we're diving into one of the biggest challenges in AI. A real head scratcher. How do you build an AI that doesn't just, memorize things, but actually understands them? And believe it or not, the key might be hiding in the 200-year-old writings of a German philosopher. It's a wild story. Let's get into it.
So there's this incredible short story by Jorge Luis Borges about a man named Funes. And Funes was, let's say, cursed with a perfect memory. He could remember every single leaf on every tree he'd ever seen, but he couldn't grasp the simple abstract idea of a leaf. He was just drowning in an ocean of details, totally unable to generalize. And that right there, Funes is the perfect analogy for a huge problem in AI today. We can build these massive models that swallow up entire libraries of data, every pixel, every word, but this can create a kind of digital Funes. The AI just overfits. It memorizes all the tiny details instead of seeing the bigger picture. So it begs the question, right? How do we build a machine that can actually think, not just remember? Well, the answer to this super modern problem might not come from a Silicon Valley lab, but from a 200-year-old book written by a philosopher who was wrestling with the exact same problem, just for the human mind.
You heard me right. Immanuel Kant, the 18th century giant of philosophy, buried deep inside his famously tough book, The Critique of Pure Reason, is an idea so powerful that it's now inspiring a whole new wave of AI architects.
See, Kant was obsessed with the similar puzzle. How does our abstract internal concept of dog, that general idea, connect to the messy real world with millions of unique individual dogs that we actually see and hear and pet? How does our mind build a bridge between a pure concept and all that raw sensory chaos? Kant's answer was something he called the transcendental schema. Now, I know, it's a mouthful, but the idea is just brilliant. He said the mind has these little mediating procedures, these schema, that act like a bridge. A schema isn't a static image of a dog. No, it's more like a dynamic rule or a mental recipe for how to construct dogness in your imagination. It's the third thing that connects our thoughts to the world out there.
And this idea, it didn't just sit in some dusty philosophy book. It's had this incredible life of its own. In the 1930s, psychologists like Bartlett and Piaget grabbed it to help explain memory and learning. Then, fast forward to the 70s, and AI pioneer Marvin Minsky used their ideas to create frames, one of the very first attempts to give a computer a kind of schematic understanding of the world.
So for decades, this was a really powerful metaphor. But now we're at a point where researchers are trying to translate Kant's bridge from pure philosophy into actual working code. They're trying to build schema right into the guts of an AI. And this is where it gets really interesting, because it sparked this huge debate, a real battle of ideas. There are two main camps trying to build a Kantian AI, and they are going about it in completely opposite ways. Okay, so you basically have two main strategies. On one side, you've got the top-down approach. This is where programmers hard code fixed, logical rules into the AI. It's rigid and it's very human-centric. On the other side, you've got the bottom-up approach, where the AI is designed to discover its own rules from the data. This is way more flexible, but could potentially create something, well, kind of alien. Let's start with that top-down approach.
This top-down philosophy is perfectly captured by the Apperception Engine, a system developed by Richard Evans over at DeepMind. The idea here is simple. Take Kant's ideas literally and build his core principles right into the AI's operating system from the get-go.
So here's how it works. The engine watches something simple, like frames from an old-school video game. Then it applies a set of pre-programmed Kantian rules, basic stuff we take for granted, like objects continue to exist even when you can't see them, and every event has a cause. And using only those rigid rules, it builds a logical, human-readable theory of how the game works. And it can do this with surprisingly little data. But, and this is a big but, there is a fundamental weakness to this fixed bridge approach. Because its core rules are all handmade by humans, the AI is essentially wearing conceptual blinkers. It's locked into our way of seeing the world, it can't discover genuinely new concepts, and it gets really brittle if the world doesn't play by the rules we've programmed into it. So if hard coding the rules is that limiting, what's the alternative? Well,
That question leads us to a second and, honestly, a much more revolutionary way to build an intelligent machine.
The question that drives this whole other approach is pretty profound. What if we don't give the AI its schema? What if it could discover them entirely on its own? This is the incredible promise behind a new idea called the curve ontology. To get your head around this, you have to see the kind of data it uses. This comes from research by Elka Kosunen, who hooked up gamers to sensors measuring their psychophysiological signals, things like heart rate, tiny facial muscle twitches, the sweat on their skin. The raw data is just a chaotic, noisy, messy stream of signals. So how on earth can a machine find any meaningful, abstract patterns, any schemata, in that jumbled mess of signals? How does it get from raw data to a concept like player frustration or a moment of excitement?
Well, this is the magic. The curve ontology AI uses clever clustering algorithms to find recurring shapes in all that data. It might discover that a sharp spike in skin response always happens during moments of high arousal, or that a really specific, complex curve in the facial muscle data perfectly matches up with the moment a player dies in the game. These learned prototype curves, they become the AI's schema. It finds them itself.
And the payoff here is huge, because the AI's concepts, the curves, are literally born from its sensory data. It solves the classic symbol grounding problem in AI. Its concepts are meaningful from the start. Plus, the whole system is adaptive, and we can actually interpret it. We can literally look at the curves the AI has learned to understand how it's thinking.
The elegance of this whole solution is just how simple it is. It all boils down to the number 2, a simple but incredibly powerful 2-layer architecture that finally bridges that gap between raw noise and abstract thought. Here's how it works. Layer 1 is the subsymbolic pattern miner. Think of it as digging through all that raw data to find those recurring curve shapes. Then, Layer 2 is the symbolic concept reasoner. It takes those curves that Layer 1 found, gives them names like arousal spike, and can then start to reason about them abstractly. It is Kant's bridge, but built from the ground up by the machine itself. This ability for an AI to build its own concepts, this isn't just a different way to engineer a system. No, it has huge philosophical stakes, and it leads to some really mind-bending possibilities about the future. So this really leaves us at a fundamental crossroads in AI. On the one hand, we can keep building AIs that think inside the box we create for them, a human-like intelligence. Or, with something like the curve ontology, we could create an AI that develops its own conceptual framework from its own unique experience, potentially creating a truly alien intelligence with its own categories for reality. And that leaves us with a final, pretty provocative question. An AI that learns its own schema might be more powerful, more creative, and less biased. But if its fundamental way of slicing up reality is completely different from our own, will we ever be able to truly understand how it thinks? Kant's ghost is officially out of the machine, and it's forcing us all to confront the very future of what it means to know anything at all. Thanks for digging into this with me.